Hi, I'm Clarence, and I'll be presenting our paper, DetermiNet, a large-scale diagnostic dataset for complex, visually grounded referencing using determiners. A determiner is an English part of speech that focuses on the quantification and referencing of the noun following it. In total, there are 44 types of determiners which belong to four classes: articles, demonstratives, possessives, and quantifiers. The learning of determiners are useful in the context of human-robot collaboration. For example, we might say something like, pass me some screws, to indicate that we want 4 to 5 screws. We might say, pass me that hammer, to indicate that we want the further hammer rather than the closer one. Or we might say, pass me either screwdriver, to indicate that you only want one of the two screwdrivers. The tasks of determiners lie in a family called the referring expressions comprehension task, where given a caption-based query, the model is required to identify the correct object in the image. There is a need to support datasets in the learning of determiners, as coverage is currently limited, and the semantics of determiners are not well covered in grounding. For example, possessives, demonstratives, and quantifiers are lacking in current datasets. We have created an organization of determiners, as can be seen in this chart. If vision language models learn determiners well, they should be able to capture the organization effectively. However, a current analysis of text encoders of vision language models, which were pre-trained on existing datasets, show that they fail to understand the semantic organization of determiners. The green boxes indicate determiners which the text encoder was able to learn the correct organization, while the red arrows show those that could not be learned. Taking clip as an example, clip is unable to identify the categorization of demonstratives such as the words these and those, as well as possessives my and your. To bridge the foundational gap in existing visual language models, we have created DetermiNet as the main contribution of our paper. DetermiNet is a visual linguistic dataset comprising of 250,000 image caption pairs covering 25 determiners. Each caption query is structured as a pass-me determiner noun format. Given an image and query, we predict one or more bounding boxes that select the correct objects and quantities. For example, the caption "These apples" indicates selecting apples that are closer in proximity and that more than one apple is selected. The nature of determiner means that there is the possibility for multiple correct answers. For example, in the scene "either apple", labeling either of the apples would be correct. To accommodate for this, we have included a ground truth correction function in our evaluation to accept multiple correct solutions. We have designed two different symbolic baseline models which serve as a lower and upper bound to our models. The lower bound is the random predictor, which uniformly samples bounding boxes from the perfect object detector. Our upper bound is the oracle model, which uses a neural network to select bounding boxes based on a perfect object detector and text encoder. Our experiments find that state-of-the-art visual language models struggle to learn determiner concepts. This can be seen from the gap in performance between state-of-the-art models like MDTR and the upper bound performance of the neurosymbolic oracle model. We have performed ablation studies by omitting noun and determiners. When determiners were dropped, performance of all models fell, showing that determiners are important for referencing the objects. When both noun and determiners were dropped, the performance was closer to the lower bound random prediction model. An analysis of the learned embeddings of the oracle model showed that it is possible for neural networks to learn the organization of determiners. Based on the LDA clusters and dendrograms, we observed that the clusters begin to resemble the determiner organization after training. Furthermore, fine-tuning on DetermiNet has the potential of improving models' performance on real images. While MDTR was trained on Cocoa images, it only achieved a 10.4% average precision when tested on 100 curated real image samples. On the other hand, fine-tuning on DetermiNet resulted in an increase of performance of 9.1%. All in all, we present DetermiNet, the first large-scale vision text dataset that defines determiner semantics to ground visual language models. We find that end-to-end models can learn determiner semantics based on the dataset design, and there is the potential for the learned determiner semantics to be transferred to real images through fine-tuning. Thank you. We hope to connect with you and advance visual grounding research together.